On October 17, 1993, a combat utility helicopter fell out of the sky over Mogadishu, Somalia. It was a UH-60A Black Hawk, tail number 88-00272. Rocket-propelled grenades tore through its tail rotor, forcing the crew into a violent, spinning descent from a height of 300 feet. According to engineering models of older aircraft, nobody on board should have walked away from that impact. But they did. In fact, the structure of the machine absorbed enough kinetic force to keep the crew compartment completely intact. That single asset changed how nations build combat aircraft forever. For 50 years, the military-industrial complex has tried to design a replacement for this machine. Billions of dollars have been spent. Multiple prototypes have flown. Yet today, the aging airframe still flies every critical frontline mission. The Pentagon cannot retire it, and over the next 10 minutes, you will understand the exact mechanical secret that makes the Black Hawk completely irreplaceable. To understand why the Black Hawk survives, you must look at the mechanical nightmare it was built to solve. Go back to 1965. Picture the dense, humid jungle of the Ia Drang Valley in Vietnam. Soldiers are packed tightly inside the cabin of a Bell UH-1 Iroquois, universally known as the Huey. The engine screams at maximum power as the pilot drops the skids into a clearing surrounded by enemy fire. The Huey was a pioneer, but it was incredibly fragile. Its fuel lines ran right beneath the thin cabin floorboards. One stray small arms round could trigger a catastrophic explosion in a fraction of a second. If a pilot made a hard landing, the single main rotor mast frequently snapped, sending the blades slicing straight through the cockpit. Even worse, the high-mounted transmission sat directly above the troops. During a high-impact crash, that multi-ton block of solid steel would tear loose from its mounts and crush everyone inside the passenger bay. Major General Jerry Harrison later noted in official Army aviation reviews that the service was losing more men to preventable crash trauma than to actual enemy anti-aircraft fire. The military did not just need a bigger transport asset. They needed an armored vault with rotors. They put out a contract for the Utility Tactical Transport Aircraft System, demanding a machine that could survive a vertical impact of 42 feet per second. Most aviation executives thought those specifications were physically impossible. Sikorsky Aircraft answered with a blueprint that rejected standard engineering logic. Instead of building a rigid frame, they designed a flexible chassis meant to deform systematically under pressure. Let us break down one system deeply: the landing gear. The UH-60 does not use light skids. It sits on massive, dual-stage hydraulic shock absorbers. Think of these landing struts as two heavy steel pistons filled with high-pressure nitrogen and oil. When the helicopter hits the dirt at high speed, these pistons compress instantly, absorbing a massive percentage of the initial kinetic energy. But the real magic happens inside the troop seats. They do not bolt directly to the floorboards. Instead, the seats hang from vertical metal columns equipped with specialized metal attenuation blocks. If the helicopter drops out of the sky, the floor may buckle, but the seats slide down their columns smoothly, using simple friction to bleed off the gravitational force before it can break a soldier's spine. Sikorsky engineers also completely rearranged the heavy mechanics. They moved the entire transmission layout lower and ran a massive titanium structural beam right over the cabin ceiling. This heavy-duty cage acts like a roll bar on a race car. It can support the full weight of the entire helicopter even if the machine rolls completely upside down. To power this massive vault, they installed twin General Electric T700 turboshaft engines. Each engine is spaced far apart on opposite sides of the rotor hub. If a missile completely blows one engine off the wing frame, the remaining turbine automatically increases its output to keep the fully loaded aircraft in the air. The real test of this architecture came on March 24, 1999, during operations over the Balkans. A UH-60L was dispatched into a mountain pass to rescue a downed fighter pilot. The weather was terrible, with visibility close to zero. As the crew hovered near a steep ridgeline, hidden air defense units opened fire with heavy machine guns. 3 rounds punched through the main rotor blades. In an ordinary helicopter, that would cause immediate asymmetric vibrations that would shake the rotor hub completely to pieces within seconds. But the Black Hawk blades are constructed around a hollow titanium spar filled with pressurized nitrogen gas. If a bullet cracks the structure, a pressure sensor on the rotor tip turns black, alerting the maintenance crew on the ground, but the composite outer skin retains its aerodynamic shape under maximum load. The pilot pulled the collective lever and forced the machine through a violent banking maneuver at 120 knots, escaping the kill zone with zero loss of control. When the aircraft finally landed back at the forward base, mechanics discovered that 23 separate rounds had passed completely through the fuel cells. Yet, not a single drop of fuel had leaked onto the hot engine components. The fuel system uses a specialized synthetic bladder lined with an advanced natural rubber compound. The moment a bullet punctures the wall, the chemical composition of the fuel causes the rubber lining to swell instantly, sealing the hole before pressure drops. The crew did not just survive, they flew the exact same airframe back into combat 48 hours later. The true scale of the Black Hawk program comes down to pure industrial volume and cash. A single modern UH-60M variant cost the United States government approximately $24 million. That might sound expensive, but compare it to its prospective replacements, which frequently top $50 million per unit before adding specialized electronics packages. The global fleet currently stands at more than 4,000 airframes spread across 34 sovereign nations. The United States Army alone operates over 2,000 separate units. To keep this massive fleet running, the logistics pipeline processes millions of spare parts every single month. Because of this massive scale, the hourly operating cost of a Black Hawk sits at roughly $5,500. For a twin-engine military asset, that number is an absolute bargain. Any country attempting to introduce a brand new helicopter platform must build an entirely new multi-billion-dollar supply chain from scratch. That financial reality creates a massive barrier to entry that modern defense startups simply cannot clear. The Sikorsky UH-60 has spent 5 decades proving that good mechanical bones beat new technology every single time. It has survived the jungles of Grenada, the deserts of Iraq, and the high-altitude peaks of Afghanistan. It is a machine designed around the cold reality of human error and hostile fire. In December of 2022, the United States Army announced they had selected a futuristic tilt-rotor aircraft to replace the aging fleet over the next 20 years. But high-ranking officials already admit the Black Hawk will remain in service well past the year 2050. It is simply too reliable, too affordable, and too tough to put out to pasture. But while the Black Hawk holds the crown for utility survival, it is not the largest machine built to handle impossible logistics. In fact, there is a giant heavy-lift rotorcraft designed by the Soviet Union that makes the Black Hawk look like a toy. A machine so powerful it can lift another entire military helicopter over a mountain range with ease. To see how that massive heavy-lift legend was built, click on the video on your screen right now. Drop a comment below if you think the Black Hawk is the greatest helicopter ever made, and do not forget to subscribe to The Hangar. See you tomorrow.